Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at creating a static library in C++. So if you've got a bunch of classes or functions that you want to reuse in other programs, of course there is the easy option of just copying your code over, and you can do that in Eclipse just by right-clicking, copying and pasting between your projects. But another thing you can do is create a library of code. And you can even then distribute that library to end users, to other programmers who can use it in their code if you want to. And there are two kinds of libraries. There are dynamic libraries, which on Windows have the extension DLL. And if I remember rightly, it's going to be like .so typically on a Unix type system. And there are also static libraries, which have the extension .lib on Windows. Last time I checked, and it's going to be usually .a on a Unix type system like this one, which is the Mac. Dynamic libraries they're shared between programs and they're loaded at runtime, and you put your dynamic libraries either in the working directory of the program, the directory it thinks it's running in, or in some special place on your operating system. So on Windows, for example, you'll have a folder containing a lot of standard .dlls, or on a Unix system, a load of standard .sos, probably several directories. We're going to look here at creating the simplest type, a static library. And now this is a library that you actually build into your code. So at the end, you would only if you're creating a program, you'd only distribute that one file, your executable, and that would have your static libraries incorporated into it. So let's take a look here at how you can do that. I've created this test library program, and this is just a normal helloworld C++ program, and I'm going to use that to test my library code. And we're going to go ahead now and create an actual library to test. So let's go in Eclipse to File, New C++ Project. And all the stuff I say here, it applies to other IDEs as well. It's just that in other IDEs, of course, you have different menus and different ways of doing things. But it always involves the same basic concepts. So here we can see I've got options to create a shared or static library in this project creation screen. Let's expand static library and create an empty project. And here on my Mac, I need to select this Mac OS X or OS X, or however you say it, GCC compiler, which is the compiler that I've just been using for this course in general. So I'll give this a name. I'm going to give it a name that's completely lowercase, because then my library name is going to just come out all lowercase anyway, which is perhaps the most common option for a library, but it's not really important. But just to have the greatest consistency with other libraries, I'll give it a lowercase name. I'm not even sure what the Windows convention is really, to be honest, these days, but let's call it animals. I don't know, maybe you want to give it, so this is going to be a library that just has a simple demonstration function and class in it that's just going to not do anything very exciting. It's just going to demonstrate the concept. Obviously, you call your library something appropriate to what it is if possible, but a lot of them do have terribly cryptic names, it has to be admitted. Okay, so we'll click Next now. And I'm going to untick debug here, just because if we create a debug version, it's going to have symbols in it that would enable us to use the Eclipse debugger. But then I don't think I've ever actually used the Eclipse debugger with a library anyway. And what I'd like to create here is a release version, which is intended for distribution to end users, or you could just use it yourself. So let's do that. I'll click Finish. Now, this is kind of works pretty much as you'd expect, really. We can go ahead and we can create classes in this library. I'm going to give you an example of one class and one function and put it in this library for demonstration purposes. So I'll right-click the project and go to New Class for a start. Let's call this Cat. So obviously, again, this is just a silly kind of demonstration. And we'll click Finish here. So now we've got a class in our library. Let's give this cat class a function that does something. So I'm going to give it a void speak. Many people say cats can't speak. My sister insists that they can. So, you know, I don't know. Anyway, right, let's get on with this. So I've created a prototype of my function in the class, and I'm going to go to my implementation file, paste it in there, and we'll say that it's a member of the cat class, and put an implementation in for it here. And now I just want to use a cout in here, just so that we can, you know, demonstrate this method actually doing something when we use it. Now, with a library, you want to be very careful about what you include and what namespaces you use. So if I went to cat.h and included iostream, for example, we're going to have to distribute the header files, not the CPP files, just the header files with the library, so that people use it, because they're going to need the prototypes of, you know, classes and functions in order to be able to use these functions in their code. So if we included iostream here, anyone who included cat.h would then also have iostream included, and maybe they would rather not have that. So since I don't need it in any case in this class, I'm going to just include it in the implementation file here, which the implementation file is only going to be included as binary code. So here includes are not so much of a problem. And another thing that I really should have done is I should have put this class in a namespace. So let's do that. Let's say here class, I'll call my namespace Caver Programming. You need an angle bracket there. And after we finish defining stuff, we close the angle bracket. And I'll do the same thing with my implementation here. Let's put it in a namespace right here. There we go. Now we're going to be using the standard namespace here. Let's just compile that because it's got errors in at the moment. What did I do wrong? I should have said namespace here. Okay, so that should fix that. We should be able to check that this compiles. Save that and this. Every time I record this video, I make some mistakes. Well, actually, this is the second time I've recorded this one. Okay. Right, so we've got our class. It's in a namespace. We've included iostream. Now, if I said using namespace standard here, so using namespace standard, which I've been doing in this tutorial, here I guess it's not really bad, but a lot of people disapprove of using this in general, because if you're using, if you say you're using a whole namespace, then if you use another namespace, or you want to include some classes from a different namespace, and there are classes with the same names in both namespaces, then you have a clash there. And this will be very problematic potentially if we were to put it in a header file, because then anyone who uses this header would be automatically using that namespace, and they're not going to like that, because that's going to import a lot of stuff into their namespace area that they're using, you know, and maybe that's going to, some classes or functions in this namespace are going to clash with the ones that the user wants to use. So what I'll do here is I'll follow, which is kind of something which is kind of considered best practice anyway, and rather than just saying using namespace, which is fine for a small project usually, but rather than do that, I'm going to do the following. I'm just going to prefix anything I want to use from the standard namespace with std::. So let's say std::cout, and I'll make a sort of cat noise in here like this, and we then need to say standard endl or endler, as I've been calling it. But someone said it's better to say endl, and I suppose I agree with them really. Okay. So that's that. Now we've got basically a functional library. It doesn't do anything very exciting, but we could use it. Let's also put a function in here. So if you've got a load of functions and a load of classes, probably it's better to put the functions in a separate header file, maybe even divide them up in different headers depending on, you know, what sort of category of things they're involved with. But this is just a demonstration, so I'm just going to bung a function in right here. Let's say void say something, and I need to create the implementation of this in my implementation file in this namespace. So let's just have another see out here. And here I'm going to say, hello there. I should probably have thought of something that relates to cats or animals, but hopefully you'll get the idea from this demo. Okay, now if we actually build this, then as long as we get no errors, we should be able to expand our project here, expand the release folder. And here you can see various files, and this is actually the library that we've created. So that was pretty simple. If you're familiar with C++, it's pretty simple to create a library. And we can also see this is the object file that was compiled just from the implementation file of the class, basically. And we've got some other stuff in there, it's not so important. But that's what we'd actually be distributing and using in other projects. We've also got this cat.h we created, and we'd also have to distribute that with the library. So now we can go ahead and use these. And what you'd normally do is probably copy these to some other folder, and then you've got a copy of your library which you can make use of. But rather than do that now, I'm just going to make my test project reference these files actually where they happen to be at the moment. So to take this library file, for example, libanimals.a, let's right click that. On Windows that's going to be probably .lib. Let's right click it and go to properties, go to this resource thing at the top, and here's the full path to where that library happens to be now. So I'm just going to copy that, click cancel, and now in my test project I'm going to right click properties, and I'm going to go to C++ build settings, and we need to go to the linker settings here. This is the thing that links together all your .o files to create your final executable in this case, or it could be a library. We'll go to libraries here. So here we have to specify a path to a folder containing libraries. Let's click plus here, paste that in. I'm just going to get rid of the actual library name at the end. I'm going to cut that because what we need is this path to the folder containing libraries that we want to use. And I click OK, so it's in there. And under libraries here, click the plus sign and just paste in the name of that library. Now we need to remove the .a or .lib, and we also need to remove the lib prefix here. All we want is the name of that library right here. We don't want the lib prefix that was added onto the beginning or the extension. So click OK. So it's using the animals library from this directory, and I'll just click apply and OK. We also need to tell our test project where to find relevant header files. So let's look at our cat.h, right click, properties, resource. Here's where it's located. So I'm going to copy, and here I just need the directory. So I'm just going to copy the directory, click cancel, go back to our test project, right click, properties, C++ build, settings, and now we've got this includes in the compiler settings. And where it says include paths here, I need to add the directory there. So this is the directory containing the header files that I want to use in this project. Click OK, and we don't really need to click apply actually, but you can, and click OK. Now I can use that library in my test project. So let's go to the test project, go to the main function here. Here I can include my cat.h, or I can include it wherever I want within this project. Let's say include cat.h, and since this is now a header that's in a standard location, in one of the locations that I set in the kind of compiler settings, I'm going to put this in angle brackets. I don't know that there's really actually any difference necessarily in all compilers between angle brackets and quotes, but usually use quotes for double quotes for local headers that are in your project and angle brackets for stuff that's elsewhere. So I'll stick to what I think is the convention here. We either need to say using namespace kver programming, or I could prefix the objects I use with kver programming : : So let's maybe do the other, because as I say, it is, this kind of thing is considered by many people to be bad practice, although I do use it throughout my course because it is easier. And if I write programs myself, I often use it as well. But it's true that it could be a problem if you're writing a larger project or something that includes a lot of different libraries. So let's not do that at all. And here I'm going to say cave of programming : say something. And in fact, my autocomplete even magically worked there. So if I run this, we should get some output that's actually coming from our library, and here it is. And we can use the classes in there as well. So I can say cave of programming : cat. And let's create an object from that cat. Let's call the cat Bob, which is an unusual name for a cat, but it will do. And we'll say bob.speak. There we go. And run this, and we should see something interesting. So I only need to prefix the types with the namespace, and that's just an alternative to writing using namespace cave of programming, which avoids the possibility of namespace, clashes between namespaces basically. So let's run this, and there we see meow, and that's coming from my library. So there you go. As you can see, it's pretty simple. If you have got basic C++ down, then you can quite easily create a static library. Okay, so until next time, happy coding.